Well, hey gang, I'm going to get a little crazy in this one. I know you like that when we do the crazy stuff. This is a travel guitar, hand-built in the USA by Go Guitars in the classy city of San Diego. And this one is made in 2011. Oh, for those of you who are concerned, yes, the arm is healing nicely. I don't know whether it was hogweed or just garden variety poison ivy, but sure was fun. I'm not wrapping it anymore. You're just going to have to look at it because, as it turns out, wrapping it was a very bad idea. It got much worse. Now it's doing better. The owner really likes this guitar. He travels and plays it and finds it's just right for his needs. And when he originally ordered it, he got a few little upgrades at that time, but now he wants to go further with it. Some of what I'm going to do will make it easier to play. It'll be functional stuff, like we're going to swap the tuners. We're going to be installing a pickup. But then there's also a purely cosmetic component to this job that's going to leave the usual bunch of unimaginative types scratching their heads because it seems to make no sense economically. As always, this is none of their concern because they don't own it and they're not paying for it. To begin with, I like this guitar. It's got a big sound for a little body. It's made from some nice materials. It's got beautiful book-matched walnut on the back here with a little flame in it. Some curly maple binding. I think that headstock facing is zebrano or zebra wood. Just, you know, really well put together. Honest construction. Seems like it was done with some care, you know. Setup wise, it's time for some work. The action is creeping up a bit. It's over 7/64ths on the bass, 6 on the treble. That's 2.7 to about 2.4 millimeters. But, you know, there's some room in the saddle to come down a bit. And also the truss rod needs adjustment as well, as the relief in the neck is around 16 or 17 thousandths at the 6th fret. Straightening the neck will probably help the action a little bit. Also the nut slots are just a little bit high. They're not outrageous, but there's room for them to come down as well. Juice those so that they're perfect. So just some little things like that to do. Okay, we're off to the races and into our very first problem. This thing uses a standard nut here as opposed to an inserted Allen key type situation. And I'm thinking it's 5/16. I measured it and that seems to be about right. Standard 5/16 truss rod, wrench, not going to happen. Try the extended socket. No, it's just too high an angle. This is my shortest 5/16 socket with the thinnest shaft possible for use with an adapter. I can kind of, it sort of grabs on the top two corners. I could probably make this work if I tried really carefully, but in the process it might become a one-time only adjustment because I'd be marring things up and you might never be able to get another socket on it again. I got a couple of options. I can either lop this thing off, make it shorter, and drill a couple of holes through the shaft here, through which I can stick like an Allen wrench or something thin and try to work on it that way. Or I can go ahead and extend this recess forward so that I get more of an angle and hopefully get more of the socket engaged with the nut itself. Now, as it so happens, the customer actually wants me to replace the truss rod cover here with some material that's going to match a pickguard that I'm going to be making. I'm going to have some tortoise pickguard material. He wants something here. So that's an option. Like, I can carve some more of this away and just make it a longer truss rod cover. That's probably the easiest situation. Again, we're removing material in a headstock, which is never, you know, a bright idea, but, you know, am I going to spend an hour making a special tool to adjust this truss rod to get rid of that 6 thousandths of extra relief? Okay, what about nut slots? I kind of mirror the angle that's on the headstock I try to round the bottom of the slot over so that the string kind of eases its way to a perfect takeoff point at the front edge of the nut. If it's super sharp or it's just bearing on a tiny little point, you'll wear through it really quickly. The other thing I like to do is also come back afterwards and relieve the back edges of the slot where the string exits so that it kind of eases into the transition of the nut, and there's less problems with tuning that way. You don't get those annoying pinging noises and the string doesn't get hung up on the back edge. Okay, with the neck straightened out, the nut finalized, I can work on dialing in the correct action here. Because we measure action at the 12th fret, which is half the length of the string, if I want to reduce that action there by a certain increment, in order to make that happen, I need to remove twice as much material from the bottom of the saddle. So in this case, where I've got somewhere close to 7/64ths on the bass side, if I want to take that down by, say, 2/64ths, I need to remove twice that material from the saddle, so 4/64ths or 1/16 of an inch. Here's a bonus tip, completely unrelated, from another guitar that I'm working on right now at the same time. Someone did some modifications to this saddle, trying to lower it, and I noticed that the outside E strings are pretty weak sounding, and here's the reason. See how it's rocking on the center point? The bottom of this is not flat. It's been sanded into a convex shape, which isn't hard to do if you're not experienced, but you do want to make sure it's good and flat. And to be honest, sometimes a slight concavity is advantageous as well. And I'm talking slight, like microns. Over time, the bottom of the saddle slot will sometimes warp along with the bridge, and usually it comes up akin to the doming in the soundboard. So if this thing is not flat, if there's not good contact, especially if you've got an undersaddle pickup, the pressure isn't the same under each string, and those that aren't contacting are going to sound pretty weak compared to those that are. So to flatten this off, I darken the underside of the saddle all the way along with pencil, and I can sand and see exactly where the material is coming off. If I want to make sure it's good and perpendicular, I have this little steel rule here. Keeping my pressure towards the outside ends, I can see that there's still pencil on either side, but the center portion is coming down. Just polishing the bone here. This thing's actually really well intonated. I'm using a small carbide burr to cut some string slots and increase the downward pressure on the saddle. I'm removing excess material from the top of the nut. I only need about half the string's diameter in the slot. I'll sand and polish that up to a nice shine. The side dot markers on this guitar start at the 5th fret, and the owner thinks that's a little silly, so we'll put one in at the 3rd fret for him as well. He also finds the choice of small plastic fingerboard inlays a little bit skimpy, so we're going to swap those out for larger ones made from mother of pearl. We're going to remove these inexpensive open back tuners. These are not of exceptional quality. These tuners have been installed while the lacquer was still tacky, and you can see that we're losing a little bit of paint. The lacquer itself is very thin. I tried heating these up with a soldering iron, and no dice. They just kept coming off. It was just like glue. So, we're gonna have to do a little bit of finish work. I'll sand that off as clean as I can. I'll plug the screw holes with some dowels. I'm going to snip these off, let that dry, and then come back with a chisel. I'll do a little more sanding. I'll touch up with a coat of shellac and then shoot a coat of lacquer over top of this. Okay, quick coat of lacquer. I think we're back in business. The customer has acquired these. They're like a mini tuner, Asian imports, much better than the ones that were on there. To make these fit though, I'm going to have to do three different drilling operations. The The first is they have a barrel that surrounds the shaft here, so I'm going to have to drill part way through the headstock to accommodate that. And they've also got these threaded bushings that go through the front surface, so I'll have to probably end up reaming those front holes to accommodate those. And I should probably check to make sure that those fit okay and that we're not too close to the edge of the headstock, and yeah, that'll work fine. These are the kind of tuners that have little ridiculous studs on the back of the housing rather than screws to attach them to the headstock. It's a ridiculous thing. No one should make these, but you know they do, so I have to deal with them. I got to drill holes for each of them, so I got a piece of straight stock here. I can line these up so that they're looking about right. And then I'm going to have to press pretty firmly to create a couple of dimples in the back of that mahogany there.
Seriously, how much are they saving by not including 6 screws? These look nice and they work pretty well. The customer has this salvaged K&K Pure Mini pickup, but it's got this odd 1/8 inch adapter on it, so we're going to get rid of that and change the connection over to a standard barrel jack. And of course I can shorten the length slightly, but I do need to leave enough that I can reach the sound hole so I can get glue on these little contacts. So we'll connect and solder up all the hot leads. Then we'll solder the ground wire. When reusing a pickup like this, it's always a good idea to test it out before you actually glue it into the next guitar. I'll clean up any of the old super glue residue using a little bit of acetone and just sort of scrape it off the surface. Ordinarily, K&K includes a fancy little device that works to position your finger inside the guitar when you're gluing on the contacts. It works with golf tees. It's very interesting. That's not going to work in this case, of course, because it's about 7 inches away from the sound hole, which is about 2 inches, so I had to come up with an ingenious little stick. It's got a dowel on it, and I'll use that to push the contacts up in the correct position. I'll augment that with another dowel that goes through the hole drilled for the end pin jack in the end of the guitar, and I'll be able to push up on it from that side as well. Great system, huh? To keep the contacts in place while I move them into position, I'm going to use double stick tape on the end of the dowel. I'll apply a thin, even layer of gel viscosity super glue, and then the clock starts. I actually figure out the position for this by sighting through the bridge pin holes with a light above them. And over the years I've figured out that I'm actually pretty good at estimating where I have to position that to get it underneath the saddle. It's not that difficult if you've tried it a few times. Once things are in the right spot, I'll apply some pressure using the stick through the end block hole, and we'll just hold things steady for a couple of minutes until the glue can firm up. We'll take a quick gander. Things ended up in the right place. Once all 3 contacts are glued in place, I'll fish the jack on through and secure it with the accompanying hardware. Okay, so the pickup's installed, seems to be functional. Now we're into the most creative and scary part of this whole procedure. Now the owner really likes this simple purfling line that runs around the body. This is a classic black, white, black purfling. And he really wishes that there was something like that around the sound hole. So the question arises, how do you cut a rosette like that in something where the sound hole is already cut out of the soundboard? Like usually it's a flat piece, we drill a small hole, that can be a pivot point for a router compass. Can't do that in this case. But I was thinking that hole there could be analogous to this small pivot hole. I could cut a plug that fits this diameter exactly and then glue something on top of it
mainly because I'm going to have to pass my router over top of the fingerboard extension, so it's got to be high enough that it will do that and not run afoul of it. I can cut a Rosette channel that way. We'll inlay some black, white, black purfling and do it like that. So we're going to see if this works. Pretty sure it will. We're going to get rid of this pickguard here. It's very thin black plastic. Earlier I traced it because we'll be replacing it with a tortoise shell plastic guard. And just like when I made the one for the Harmony in that series of videos, I'm going to have to thin this stuff down. This is 2 millimeters thick. I want it to be about 1 millimeter, so something you would find like a 1950s Martin guard. So we're going to make something like that. We're going to duplicate this in this plastic, but I can get rid of it now. It's so thin it probably wouldn't really affect the router compass, but you know, it's got to go anyway, so let's take it off. You can see the color of the Sitka spruce as it was originally. After 9 years, it's darkened and oxidized. It's kind of a satisfying job. So after almost a decade, this thing probably isn't a perfect circle anymore. They tend to warp into an oval over time with seasonal changes. And yeah, it's actually substantially larger across the grain than with it. So probably the best thing to do is make a plug that's a little bit undersized. I can wrap some masking tape around it and create something that's compressible so that hopefully it'll stay relatively centered. Let's set up my fly cutter here for an outside cut.
No one's ever looked at a fly cutter in operation and said to themselves, boy, that looks like a calm, safe, reassuring kind of device. Yeah, let's just raise that arm up a little bit, shall we? Aw, isn't that great? It's a little too tight. We get to do it all over again.
So I've wrapped some tape around the plug to make sure it's good and snug longitudinally, and also padded out the sides of the sound hole. So this thing now goes in nice and snug, very little play.
I'll glue a couple of rounds together. The drill bit's just there for alignment. I'm marking the inside of the Rosette channel, and I can position the compass device. As you can see, I didn't go to great lengths to make it look all that visually appealing, because this is like a one-time only jig. I've got this 16th inch cutter. It's a carbide cutter. I can position the router so that it's in the right spot. Then I can screw the housing directly to the jig. I made sure these screws weren't long enough to go all the way through that top disc, because that would be disappointing. I can set the depth of cut, which is going to be about 1.2 millimeters. I've got to go slow because this is a small bit and it's cutting almost as deep as it is wide. Don't want to force it. That's actually a very reasonable cut given the situation. I can slice those little fuzzies away with an X-Acto knife. Doing a test fit here. I actually heat bent this because the 3-ply lamination is pretty stiff. I used my little electric bending iron. So when fitting this kind of rosette, where it's not being disguised by a fingerboard extension, it's really difficult to get a nice clean join that's invisible. I find it's best to actually slice that off at an angle, making a miter joint rather than a butt joint. Just like that. I get glue into the channel in quarter hemispheres. You don't want to go too far because the glue can actually swell the channel up and make things really tight, so kind of work fast. Just for added insurance, I'll flood the top with some slightly thinned glue as well. Let that soak in and wipe off the excess. While that dries, I'll start work on the pickguard. I used a thickness sander and brought it down from 2 millimeters to about 1.2-ish, maybe 50 thousandths of an inch. And I'll scrape and sand it smooth. I made a routing template from the template I traced from the previous guard. I'm going to super glue that directly to the tortoise shell with some masking tape in between. These are dangerous activities undertaken by an experienced woodworker, so you've been warned. I'm serious about that. If you didn't know better and tried to push this in the wrong direction, it could grab the work right out of your hands or maybe even pull your fingers right into that spinning blade, and it really wouldn't be pretty. It seems simple, but, you know, all of my concentration is going right into this little 3-inch space here. I know every movement in advance, I know every shift of weight, I know all the escape routes. So this is not for beginners. You're better off using a sander. We'll knock some excess height off these exposed lines. Using a Japanese carving chisel here with a really acute angle riding on the bevel. It looks like I'm pushing harder than I am. This is a really delicate touch. Just coating the exposed surface with a little bit of water-based finish. I'll come back afterwards with some very fine Scotch-Brite pad and kind of blend the surface into the existing one. Using a razor blade to scrape a bevel into the top surface of the pickguard. The protective plastic is still on at this point. Using masking tape here to make a hinge. And I'll remove the backing from the double stick tape, which I'll use to stick it down with. And then peel off the protective paper. I made the new cover for the truss rod. And I think we've come to the end of another project. That looks pretty good. Shiny. So let's hear what it sounds like.